Carbon fiber has been a hot topic in these recent years with its presence in the automobile industry, aerospace industry, fashion industry, as well as many other aspects. The reason to why it is becoming so popular is due to its strength of carbon strands woven together, creating a very high strength material. Carbon fiber is becoming a major necessity and will continue to grow in value and demand. Knowing more about the creation, economics, and use about carbon fiber is key into understanding the popularity of it. All topics assessed will be important in the upcoming wave of carbon fiber's popularity. Firstly, the history and reasoning behind the use of carbon fiber will be administered. Shockingly, carbon fiber was first created around 1879 by Thomas Edison, and the reasoning behind the creation of carbon fiber was initially to use the material as a filament in some of his first light bulbs he began to create and experiment with. Although at the time, the initial thought of using it for its tensile strength was not thought of, the fact that it could handle heat and high temperatures very well compared to other materials as well as its conductivity made it a point of interest in the future. It was not really popularized until the 1950s when manufacturers and consumers were looking for a material that could withstand stresses and heat, and ultimately carbon fiber was unmatched at the time. Then the question arose of what was the best way to efficiently and effectively create carbon fiber in order to get it out to the public. To create and produce carbon fiber, thin strands of carbon material woven together and creates carbon fiber, otherwise known as graphite fiber and or carbon graphite. Carbon fiber is actually known for strengthening other materials. However, the carbon fibers themselves would have a chemical formula of C to the single bond of C to the double bond of C to the double bond of C to the single bond of C. The individual carbon strands are heated together to a high temperature, hot enough to produce vibrations within the individual strands, but not to a high enough temperature to burn the strands of carbon being heated together. Since carbon fiber would typically melt at 3,652 to 3,697 degrees Celsius, so it can withstand the high temperatures needed to separate the carbon atoms without necessarily melting or becoming weak. The different carbon strains vibrate at violent frequencies to the point where all non-carbon atoms are released, creating a truly all-carbon strand that can further be used to complete the process of creating carbon fiber. After the process of heating and getting all the unwanted atoms out from the strands being heated, the strands of pure carbon are then woven together either within different fabric materials or other materials to make the item/object stronger and lasting, depending on the use of the carbon fiber. Due to the process of making the strands pure carbon, carbon fiber creates covalent bonds, which is its primary bond. A reason carbon fiber is so strong is also due to its crystal structure. Carbon fiber has a HCP crystal structure type, which is hexagonal crystal shapes as shown on the screen. As well as its crystal structure of carbon fiber, some scanning electron microscope images are shown on this slide. Although the process of creating carbon fiber is rather long, this is what drives carbon fiber prices up. Prices also depend on if the carbon strands are woven in or around another material, which also help makes the carbon fiber stronger. And the strength of carbon fiber is one of its biggest selling points. One of carbon fiber's biggest selling points and uses is its tensile strength and structure. The way carbon fiber is formed, as explained previously, the carbon strands are strong and the carbon fiber as a whole is even stronger than some metals and steels being used in the current market. Compared to steel, carbon fiber has a tensile strength of 3,000 megapascals. Yet the steel is around 1,500 megapascals. And that measure is not even the measurement of traditional steels. It is purely carbon-infused steels. The slide currently being viewed is the stress-strain curve under compression. Along with its strength, carbon fiber has a much lower mass than most common metals and steels being used currently in the industry. The density of carbon fiber is 1.5 to 1.7 grams per centimeter cubed, which is almost incomparable to steels with a density of about 7 times that. With a yield strength of 1010 gigapascals, it can withstand a monumental amount of force before fracture. The sheer fact that of the strength and weight of carbon fiber creates a huge impact on racing, aircraft, motorbikes, and bicycles, marine equipment, etc. With it having such a high tolerance to temperatures, it has lots of thermal properties. The electrical and magnetic properties can depend on the material carbon fiber may be used with. However, not only can carbon fiber withstand high heat and could potentially possess some electrical and magnetic qualities, carbon can also withstand a bit of elasticity when put under stress. With an elasticity of 228 gigapascals, carbon fiber can get back into shape quite efficiently, effectively having a high ductility value. Although carbon fiber has its many advantages, there is some downfall. Firstly, being compared to steel and other alloys, carbon fiber has a lower toughness at just 2 on the Moyes scale. Also, with a shear modulus of 4 gigapascals, it remains on the lower end of the spectrum for shear values compared to other alloys. It is becoming more and more common the more that carbon fiber is being investigated and looked over due to the different types and amounts of strands and types of carbon fiber being created. It will only become stronger, better, and lighter with more time while it is being researched. There will always be a need for carbon fiber, whether it truly does make an impact or not. This is due to the fact of people making carbon fiber more popular and sought after due to its appearance and popularity, which will ultimately make it more desirable and sought after by people who are wanting to make a statement or to be seen by peers as more wealthy. Carbon fiber is seen as trendy, fashionable, and luxurious, which is a big reason why people can see carbon fiber being implemented with higher-end vehicles, cosmetics, and other items. Due to the price of carbon fiber along with its many benefits, it is seen as an upper-class item or material and is being made popular with the current day market. Top car brands such as Ferrari, Lamborghini, Maserati, Audi, and various other supercars are infusing carbon fiber into their products, and objects, which also adds to the car itself. Private jets and aircrafts can be seen incorporating carbon fiber into their vehicles due to the lightness of carbon fiber, as well, yet again, the price and need for carbon fiber to make a statement. Yachts and boats often use carbon fiber as well to help with buoyancy and price. As more people find the need and want of carbon fiber, the more it will be seen as a needed item to gain popularity or status in the society. So what does this mean for carbon fiber economically? Ever since carbon fiber has become increasingly popular, the price has dramatically increased. The base price was for minimal profit and mostly was affected by the labor and complexity of making carbon fiber with its different strands. However, as there becomes more uses and needs for carbon fiber, there is becoming a demand, and with demand comes a price increase. Companies and people everywhere are finding more and more benefits and uses for carbon fiber, so it is obvious why it is becoming more expensive. Surely the price will level out, but even for the future of carbon fiber, it will always be sought after and used in every way possible. There will always be a demand for carbon fiber, and the more it gets used in the present day, the more it becomes apparent that it is affecting the economy as well as other aspects of the world. However, as it becomes more used in one, a waste of carbon fiber begins to present itself. Carbon fiber can be quite expensive, ranging anywhere from $22 to $1,500 per kilogram. However, with all of the previous qualities mentioned, consumers will be more than willing to purchase carbon fiber in the near future. As for CO2 and oxygen, There's not much data for the CO2 footprint of carbon fiber, and the possible reason behind this is firstly, with carbon fiber doesn't use too much CO2 for its process, but secondly, there hardly being a truly recyclable process for carbon fiber. However, if the carbon fiber is heated so it can be molded into a new object, CO2 would be needed in order to either create the heat or need to be expelled in order to have more heat to mold the carbon fiber. As for the water, in the recyclable/reusable process, it is hard to actually find a way water could be used this way. Possibly using water to cool carbon fiber once heated during the creation process is where water is used, and reusing the water by purifying it is a way to recycle the water. As for recycling carbon fiber itself, it's actually quite hard to recycle. The reason being, you cannot extract the carbon strands from the materials being used or crush/melt carbon fiber in order to make it into a new material. However, carbon fiber can be used for certain chemicals as a tester for different agents or a test object in an experiment. Or the pieces of carbon fiber can be reused into a new material. As shown, carbon fiber is growing increasingly popular with its presence in present-day society. This is why knowing more about carbon fiber as described in this presentation is crucial to understanding its need in the present day. The effects it has on the many different industries as well as economically and why it is becoming popular is becoming known and will continue to grow in popularity.